let's set the parameters. This is Algebra 1 pre-course, so this information is going to be somewhat new, somewhat review. There will definitely be concepts that are new to you, but this is why we do it over the summer, is to prepare ourselves and maybe learn a little something. So when you see it in class, you will have a foundation to this information, and you can build off of it. So question number 1, letters A and B represent non-zero constants. Solve ax plus b equals 56 for x. So this is just, we're isolating for the variable x. Something is multiplying it. A is multiplying x, and something is being added to x. So as we remember, whenever we isolate variables, we are going to get rid of things being added and subtracted. So that leaves us with ax equals negative b plus 56. They are unlike terms. These cannot be combined, so that's why. And we always put the variable before the constants. And now we're going to divide by a, and we get x equals the opposite of b plus 56 over a. And that was really simple. When we have multiple variables, we like that because, unless they're like terms, we can't simplify it. So much of this can't be simplified. So that would be the answer we would expect from you. Number 2, you are 5 feet 4 inches tall and cast a shadow 8 feet long. At the same time, a nearby utility pole casts a shadow 70 feet 6 inches long. Find the height of the utility pole. So here's a person, and this person is 5 feet 4 inches tall, and they cast a shadow. So let's find a shadow. They cast a shadow that is going to be 8 feet long. So there's the head. Let's draw the head here. So my shadow, there's my head, there's my hands and my feet. So that shadow is going to be 8 feet long. 1 dash is foot, 2 dashes is inches, IN. That's how I always remember it. And now you have a utility pole, okay, and it casts a shadow 70 feet 6 inches. So you have this utility pole that's got the little things on it, right? That's the wires. If you ever see those, it's called a telephone pole also. Utility pole, utilities, electricity, cable. Those are utilities. We don't know how tall this utility pole is. Okay, it's certain, but its shadow and this shadow is, I think it was 70 feet 6 inches is the shadow. Okay, so what we can do is we can write a proportion. We can write 5 foot 4 inches is to 8 feet as x is to 70 feet 6 inches. This is the height of the original, and that's not how you spell height, H-E-I-G-H-T. This is height, and then this is shadow. Okay, so the height of the object is 5 foot 4 inches, x, and this is person, and this is utility pole. All right, now we can't have these dual units, 5 feet 4 inches, so we're going to convert them all to inches, convert them all to feet, whatever. It's probably easier to convert them to inches. So 5 feet is equivalent to 60 inches. Let's do it that way, because there are 12 inches in every foot. 12 times 5 is 60. So plus the 4 inches gives me 64 inches. 8 feet is equivalent to 96 inches. I don't know how tall the utility pole is. 70 feet is equal to 840 inches. 7 times 12, 14, yeah. And plus the extra 6, so 846 inches. And now this proportion is all in inches. We can cross product, so we can do 64 times 846 equals 96 times x. I'm not going to multiply these just yet. I'm going to divide by 96 because maybe I can reduce this by something that I'm familiar with. So I can make that 32. I can make that 48. I can make 32 and 48. So 4 goes into 32. 8 times 4 goes into 48 12 times. And 4 goes into 8 twice. 4 goes into 12 3 times. And now I can't do the 2 and 3 anymore. But maybe I can do the 3 into 846. That's 18. And 3 goes into 18. So 3 goes into 846. So I can divide this by 3. Let's divide this by 3. That's 2. That is 8, 2. And now we have 2 times 282, which is 4. 8 and 8 is 16. 564. I probably shouldn't have written it in red. 564. So that's 564 inches equals the telephone. Now we got to C, find the height of the utility pole. Okay, since it didn't say in feet or anything of that nature, we could say 564 inches. If we want to divide that by 12, divide that by 12, 564. So let's reduce that by 2 is 6, which is 282. Divide that by 2 is 141 by 3. And that's divisible by 3. So that gives me 3 goes in 4, 21, 47. So that's 47 feet is the pole. So either 564 inches or 47 feet. Good. Solved. So we have an absolute value. Number one step, always isolate the absolute value. We have to get the absolute value bars by itself, so let's add 10. We get the absolute value of 4x minus 6 equals 26. And so what this is saying is, hey, what number has a distance of 26? Well, negative 26 and positive 26 could be in here. So what we do is we write two statements. We write 4x minus 6 can equal 26, or 4x minus 6 can equal negative 26. Because if I have negative 26 in here, I have to take the absolute value, which would give me 26. And now we solve. So 4x equals 32, divide by 4. X can equal 8. Add 6, 4x equals negative 20, divide by 4, divide by 4, we get x equals negative 5. So my two solutions, and we write them in numerical order, are negative 5 and positive 8. Negative 5 times 4 is negative 20, minus 6 is negative 26, then we take the absolute value of negative 26, and we get 26. That's why this is a solution. And then 8 times 4 is 32, minus 6 gives me 26, and the absolute value of 26 is 26. Very important concept. Write a number b minus 6.7 is at most 9 as an inequality. So a number b minus 6.7 is at most, meaning it can't be greater than, it is at most. It needs to be less than or equal to 9 because its largest value is 9. So that's the proper way of writing that equation, or inequality, excuse me. Now we want to solve the inequality and then graph the solution. So when we have inequalities, they're very similar to solving equations. We isolate the variable by moving using the inverse operation, and then we're going to multiply by 3, and we get x is less than 12. Now we have to remember that when you have less than or greater than, that the inequality, this is the inequality sign. Are we the circle and line? Well, let's do. The circle is going to be open because it's not including. If we have less than or equal to or greater than or equal to, we're going to have a closed circle, and that means including. So since this is a less than, we're going to have an open circle over 12. And I always like writing where 0 is, and then I'll do my number. It'll be an open circle, and it says the solutions are less than 12. So solutions that are less than 12 are here. And it's always important, I would advise you, another advice is always write the variable first in inequalities. It just helps you with graphing your solutions. Same thing here. We have 9x minus 7 is less than or equal to 7x plus 9. Much like equations, I would advise you to move the variables first, not the constants. Then we're going to add 7. We get 2x is less than or equal to 16. Divide by 2. Divide by 2. X is less than or equal to 8. This time it's going to be a closed circle. I'm going to show where 0 is and 8. I'm going to do a closed circle. My solutions are less than or equal to 8. So it's going to look like that. And I always put my graph above. If we put it down on the graph, it just gets in the way of the other material, and it's just too busy. So I always like writing it above. Oh, okay. So this is a compound inequality. And these are less than, so it's going to be an and. So we have negative 17 is less than 2x minus 5. Let's put this over here. And 2x minus 5 is less than or equal to negative 7. So notice this middle statement. Notice this little middle part gets both of the pieces. So we get it with that, and then we get it with that. So negative 17 is less than 2x minus 5. And then we write a statement, and 2x minus 5 is less than or equal to negative 7. So this statement has to be in both of these pieces. And now we solve it. So we'll add 5, and we have negative 12 is less than 2x, divide by 2. Negative 6 is less than x. Remember how I told you I would write my variable first. It's eating the variable. So this makes a whole lot more sense. X is greater than, opposed to, this seems like a less than. A lot of students would write less than, but it's actually a greater than. And then we're going to add 5. 2x is less than or equal to negative 2. Divide by 2. And we get x is less than or equal to negative 1. And so this is an and statement. It has to be true for both statements. So if I graph this part of it, x is greater than, well, let's do the numbers. Let's do negative 6, negative 4, negative 2, 0, 2. So if I do the green statement, x is greater than, open circle, greater than. And if I do this statement in blue, x is less than or equal to negative 1, that looks like that. Now the question is, where is it and needs to be true, true? Both need to be true. And I call that the true, true. So it's true for blue, but false for green. Right at this intersection, it's false for green, true for blue. But right here, it's true for both, true for both, true for both, true for both. And now it's only true for green, but false for blue. So that's going to look like this graph. So we would rewrite that graph. I would not have that other part anywhere near it. -1, 0. So we have an open circle and then a closed circle over -1. That's what the solution looks like. And that's a good representation of all the solutions to this compound inequality. I don't want to see this in the answer because I'm not certain you know what the answer is by there. So we would just write it as a standalone. Absolute value, remember, isolate the absolute value first. So we have 6 times the quantity of the absolute value of x plus 6 minus 3 is less than 9. This is an absolute value inequality. We still isolate 6 times the absolute value of x plus 6 is less than 12. Divide by 6. Now we have the absolute value of x plus 6 is less than 2. Now less than is going to be always going to translate to and. It's an and statement. Greater than or less than or equal to, and greater than or equal to. But greater thans are always going to be an or statement. And needs to be true, true, or at least one true. So we need at least one to be true. Sometimes it can be more than that. So we're going to write the two statements. Remember, this can have two statements. You can either do x plus 6 can be less than 2, and x plus 6 must be greater than or greater than -2. Remember, we have that positive and negative, and when we have that negative, when we multiply by a negative or value that negative, we have to flip the inequality sign because inequality signs get interesting. And -6 minus 6, x is greater than -8. Okay, let's draw. What does that look like? So we have -8, -4, 0. Let's draw this in green. X is less than -4, open circle going to the left. Let's draw this. X is greater than -8, open circle going to the right. So where is it true, true? And needs to be true, true. So right here, so now I would rewrite this diagram, this number line, -8, -4, 0. I'd have an open circle, and this is my solution. Yes, perfect, love it, good. Find the domain and range of the function represented by the graph. Well, domain, remember that means your x values, and range is your y values. So what is the set of x values that you have? Well, it starts at -2 and it goes to all the way to 4. So x is, or my domain, excuse me, they call it domain, is going to be -2, and it can equal -2, and my x values can go all the way up to 4. So my x values are greater than or equal to -2 and less than or equal to 4. My range, my y values, well, they go from 4 to -3. So I'm going to write -3, and we can include -3. That's a solution, and that goes up to 4. So now I'm just looking at my y values. So it goes from -3 to +4. So that's the way you would write your sets, would write your solution for the set of numbers for your domain and range. Describe the end behavior of the function. Okay, so when we talk about end behavior, that's your y's, and we want to know by your x's. So, you're going to write as x goes to +infinity, what does your y do? Well, your y is going to go also to +infinity. Because as x increases, y increases. And as x decreases, as it goes towards -infinity, what happens to your y? As x is increased this or decrease this way, well, my y is going to continue to go again. In this situation, it's going to go towards +infinity. So that's how you would write that diagram. That's infinity sign. And that's it. That's a good one. End behaviors are really important. That's definitely a more complex idea that we will go over this year in the first couple of chapters. Keep working. You're almost there.